All right, and then moving on to 7.2, number 13. So we've got integral of ln of 3x minus 2. Now, so again, the more you practice, the more experience you gain, the more like a solution will sort of just jump out at you. So personally, when I see this, my mind doesn't go directly to integration by parts, although I will use that. But the first thing I think of is u sub, right? Do a u substitution. Because I know that if I let u be 3x minus 2, that'll just clean up that inside of the function, just make it u. And the derivative is just a constant, which I can move out of the integral. So it's going to make things so much cleaner and nicer. You know, if you make that substitution, this basically just amounts to integrating ln of u, which we kind of did in number 11 already, right? We did ln of x, and this is just exactly the way that you do it, right? So do a u substitution first, and then just do what you did in number 11 here, and you've got it, right? It's a piece of cake. If it didn't occur to you to do a u substitution first, and you were just thinking about trying integration by parts, then what you would have set up, you know, you would have been forced to do this, right? There's really no other option. Now, when you differentiate ln of 3x minus 2, you're going to get 1 over 3x minus 2 times the derivative of 3x minus 2, which is 3. So when you put that together, you're going to get 3 over 3x minus 2. And then when you integrate dx, you're going to get x. So now, just like before, we have to think, you know, well, where should I stop here? Should I continue forward? Should I stop now? Well, if we continue forward, what's going to happen? You can call this 3x minus 2 to the negative 1. That'll make it a little easier to differentiate. So this would be 3 times 3x minus 2 to the negative 1. And then you can use a chain rule. You could say, well, it's negative 1 times 3. So negative 3 times 3x minus 2 to the negative 2, right? So negative 3 times 3x minus 2 to the negative 2. Oh, times 3 again, right? So times 3. So really that's going to become a 9. So negative 9 times 3x minus 2 to the negative 3. And then this becomes x squared over 2. But you always end up integrating the bottom line, right? So if I multiply those two things together, is it going to be easy to integrate that? Is it going to be any easier to integrate that than it was to integrate the previous line? And the answer is no, right? In fact, it's going to be more difficult, I would guess. So I think this would be the place to stop. Now, the problem with that is this isn't particularly easy to integrate either, right? Because you're going to have x ln 3x minus 2 minus the integral of 3x over 3x minus 2 dx. And that presents a bit of a challenge, right? Because, well, you know, if you try doing a u substitution, you let u be 3x minus 2, you don't have the derivative sitting up there. You could solve for x maybe. You could probably do a u substitution at this point. Let's try it. If you let u be 3x minus 2, then x would be u plus 2 over 3, right? Or in particular, 3x would just be u plus 2. So we could replace that with u plus 2. And here we'd get du is 3 dx. Okay, so putting that all together, I can replace the 3 dx with a du. I can replace the x with a u plus 2 over 3, which really I'll just end up pulling out. So I'm going to have x ln 3x minus 2 minus, I'm going to take this 1/3 out, 1/3 times the integral of u plus 2 over u du. And then that's actually, okay, so we could do this. Yeah, this is doable. because we can split that. We can split that numerator and call it u over u is just 1. 2 over u is just 2u to the negative 1. And we're almost there. So this is going to be u plus, I don't know why I rewrote it as u to the negative 1. So it would be 2ln absolute value of u. Okay, and then we can make the replacements. So u was 3x minus 2. Minus 1/3 times 3x minus 2 plus 2ln, the absolute value of 3x minus 2, plus c. Anyway, and you can try to simplify that. But let me just show you how this would have gone down if we had just done a u substitution first. So my inclination was to say, okay, we've got ln 3x minus 2 dx. Let u be 3x minus 2, right? Then du is 3 dx. I can give myself a 3 dx by offsetting it with a 1/3 there. And so this is going to become now 1/3 times the integral of ln of u du. And now to integrate that, I'm going to use integration by parts, right? So I'm going to say ln u and du. I get 1 over u and u. So this is going to be 1/3 times u ln u minus the integral of du. So that's 1/3 times u ln u minus u plus c. And I can back substitute now, right? U was 3x minus 2. So this is 1/3 times 3x minus 2 times ln of 3x minus 2 minus 3x minus 2 plus c. And you may think, well, that doesn't look like what we got before. I mean, you could. I'm sure that if you worked at it enough, you could get them to be this. You could get them to look the same. You could get them to work out to be the same thing. I mean, so it's just algebra. Getting from here to here is just algebra, right? So that's that. That's all I'm going to say about that one.